Good morning, ma'am.
Good morning. Why are you all late? Only 3-4 people have joined till now.
मैम वो सर एक क्वेश्चन करा रहे थे.
Okay, fine.
Good morning, ma'am.
Good morning.
Good morning, ma'am.
Good morning, everyone.
Good morning, ma'am.
Morning, ma'am.
Good morning. Kindly mute yourselves for a couple of minutes till I start the class. Okay. Mute yourselves. Amit.
Good morning, ma'am.
I think we should start the class now.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay, so we were doing coherent and incoherent sources. What are the examples for coherent sources?
Laser light.
Laser light. And incoherent sources?
Tube light.
Tube
Monochromatic
lights,
light.
fluorescent light bulbs, and incandescent light bulbs or fluorescent lamps. Okay, so we'll move to interference of light. You have studied this, right, in your 12th class? Interference of light.
Yes, ma'am.
Okay, so can any one of you tell me what is interference? Like in short, in brief.
Superposition of two waves.
Superposition of two waves. Okay, that is one part. It is due to superposition of waves, but what is interference? What is the resultant phenomena? Yeah, it happens because of superposition of waves. But what is the resultant phenomena?
Formation of maximum.
What?
Ma'am, fringes occurs after superposition of two waves.
Yeah, there
From
is. Yes. So there is a pattern of alternate bright and dark fringes due to interference of light. So what are the conditions for interference? Like why interference of light happens?
Ma'am, coherent sources.
Due to the intersection of crust and intersection of crust and intersection of crust and crust.
So that is the process. That is the process. I'm asking you the conditions. What are the basic
Ma'am,
conditions?
Coherent monochromatic sources of
Yeah.
same frequencies and fixed the
Same
constant path
frequency.
difference.
Yes, the frequency when two light waves of same frequency and constant phase difference traverse in same direction. Then they superimpose on each other, and the resulting pattern of alternate bright and dark fringes is called interference. So what happens is, suppose this is the light source. It emits monochromatic light, light of a one wavelength or one frequency. So we have placed these two slits S1 and S2 in the path of light. The distance between these slits is D. So why we are taking two slits S1 and S2? To divide this light into two sources further, which will superimpose with each other, and we will get interference pattern. So to get the two waves to superimpose, we are taking two sources. We are placing two slits S1 and S2 in the path of light. Okay.
Yes.
So what happens is the waves from slit S1 and S2, it goes in all directions, right? Like this. From this slit also, the waves goes in all directions. Why only these two rays are shown here?
And they are
Anyone?
moving in same direction.
Actually, the thing is, this light from source S1 and S2, they move in all directions. They superimpose with each other. We are taking these two rays because we want to see the resultant of superposition of these two. Actually, in general, a large number of waves are there and they superimpose on each other. We want to find the intensity of light at a general point P. Okay, we will extend our discussion to whole screen. This is a screen. Why we need a screen to see the resultant pattern of interference? If there is no screen, what will happen?
Light will pass into
You
vector.
can't see the intensity of light.
If
and
we
the
want to
point.
see the pattern, there should be some screen
We
on
will
which
not be
light
able
will.
to.
Yes, sir.
Yes. So there should be some screen on which light will fall and we will be able to see the pattern. So there is a screen to view the interference pattern. It is placed at a distance L from the two slits S1 and S2. So the light in general goes in all directions from slit S1 and S2. We have only shown these two rays because we want to see what is the resultant of these two waves in particular at the point P, which is at a distance, let's say, X from the central point O of the screen. So don't confuse ke yahi do rays and there are a number of rays. So we are considering only these two because we want to simplify first what will happen when these two waves will interfere with each other. So what happens is these two rays superimpose on each other. What will be the resulting pattern? We will see. So first of all, what is the principle of superposition? It states that at any particular point, in this case of interference, let this point be P. At any point, the net displacement, resultant displacement due to two or more waves is equal to vector sum of displacement due to individual waves. So if there are two waves like this is wave number 1, this is wave number 2. They are meeting at a point P. So the resultant displacement at point P is equal to the vector sum of y1 and y2 if the two waves we are considering, that is displacement due to wave 1 at point P is y1 and displacement due to wave 2 at point P is y2. So the net displacement at point P due to these two waves is y1 plus y2. And if there are three waves or multiple waves which are superimposing, we simply extend the addition. Here. So why we have written here
Yes,
vector
ma'am.
sum? Why we have written here vector sum? Okay, that will be clear in next slide. So interference is of two types, constructive and destructive. In case of constructive interference, what happens?
Amplitude increase.
So wave in general has a crest and trough, right? So this is wave number 1. And if the superimposing wave number 2 is
मैम
also like this.
जब
Yes.
कंस्ट्रक्टिव
So
इंटरफेरेंस
if
होगा तो एम्पलीट्यूड बढ़ जाएगा.
yes, so if these waves are superimposing, we are taking the example of these two waves only. Let's imagine the wave which is going at point P, wave number 1 and wave number 2 are such that crest of first wave falls on the crest of second wave and trough of first wave is falling on the trough of second wave at point P. Suppose waves are going like this. This is wave number 1 at point P like this. And this is wave number 2. So at point P, they are in same phase. The phase is same. So crest will fall on crest and trough will fall on trough. That will, in that case, point P will have constructive interference. You visualize this now. If we move along the screen, there will be number of points. At those points, wave which are superimposing, they can have different phase. We are considering a particular case where at point P, the crest of the wave 1 falls on the crest of wave 2. Hence, it is a case of constructive interference. And what will happen in constructive interference? The net amplitude, the resultant amplitude at P, it will be the sum due to two waves. So it will increase like this. Now suppose at point P, we will suppose that the two waves which are coming, this is wave number 1. This is wave number 1 and this is wave number 2. Suppose now it is reaching such that they are out of phase with each other at point P. That is, crest of first wave falls on trough of second wave. Then what will happen at point P? What will be the resultant intensity?
0. I'm less than initial.
If the amplitude of two waves are same, which is the case for interference, the net amplitude will be 0 or intensity will be 0. If the amplitude are not equal, mute yourself. From whosoever background noise is coming, mute yourself. So if the amplitude are equal, the net intensity is 0. Can anyone tell me what is the relation between intensity of light and amplitude of wave? Intensity, I'm talking about intensity at P, intensity.
Ma'am, intensity refers to how bright is light at that point or low.
Yeah, that is true. I'm asking intensity and amplitude relation. Amplitude of the wave.
A square is equal to I.
Yes, intensity is proportional to amplitude square. Yes, and for simplification, we can take intensity is equal to amplitude square. Actually, they are proportional. Intensity is square of amplitude. Okay. Okay, so now due to constructive interference, the net amplitude is 0. That is why at point P, net intensity will be 0. So in case of constructive interference, it will lead to a bright fringe at point P. And if at point P, there is destructive interference, then It is a case of dark fringe. Now, how can we tell that there will be bright or dark fringe? What is the criteria? That point P, if I ask you, point P will be a dark or bright fringe. How can you tell me? What is the criteria which will define?
Ma'am, it depends on constructive or destructive interference.
Yes, I'm asking why, what is the criteria which will tell that there will be constructive interference at point P or there will be destructive interference at point P?
Constructive
What will
interference
decide?
से path interference 0 हो जाएगा.
Yes, but what will decide? Who will decide that waves will reach?
Intensity of
Phase
No, you listen to my question first, okay? I'm asking you, in case of constructive interference, the waves at point P, they reach in phase with each other, right? And in case of destructive, the waves reach at point P out of phase with each other. So what will decide that waves will reach in phase or out of phase with each other at point P?
It depends on phase angle.
Yes. Path difference. The path difference traveled by the two waves will decide that they will reach in phase with each other or out of phase with each other. First, you write this down. You write the definition of interference. Then we will move on. You first write the definition.
मैम फिगर भी बनाना है.
नहीं रफ पे नोट डाउन कर लो एक बार.
Yes, ma'am.
Okay, noted. The
Yes, ma'am.
figure also roughly figure you can draw because it will help you for further discussion. An elementary figure you draw. Is it done?
No, ma'am.
Yes, ma'am.
Done, ma'am.
Okay. Quickly write the principle of superposition. You can just write these two expressions quickly.
Done, ma'am.
Okay. Should I move to next slide?
Yes,
Yes.
ma'am.
Okay.
Yes.
Write constructive interference. Just draw the figure. Just draw the figure.
Yes, ma'am, done.
Ma'am, can you please show the previous slide for just a minute? Okay, thank you, ma'am. Now you can change.
What is the unit of intensity? It's,
Joule per second.
it's watt per meter square. Joule per second per meter square. Power per unit area. The units are power per unit area.
Ma'am, here W is what?
Watt, yes. Ton.
Yes, ma'am.
Okay. So I was asking you, what is the condition or criteria that point P will be a point of dark fringe or bright fringe? So it depends upon the path difference or phase difference. So in terms of phase difference, what is the condition for maximum intensity or constructive interference? Constructive interference, the waves should be like that crest falls over crest and trough falls over trough. When will this happen? When the phase difference is either 0 or it is a multiple of 2 pi. Right? In that case, when the phase difference is 0, you can see the crest will fall on crest. Suppose it has a phase difference of 2 pi. What will happen? The first wave and the second wave. If the phase difference is 2 pi, it again starts from this point, like from the origin. Again, it will superimpose this way. So if the phase difference between two superimposing waves is 0, 2 pi, 4 pi, 6 pi, and so on, that is integral multiple of 2 pi, what will happen? There will be constructive interference. So in the terms of phase difference, the phase difference should be equal to integral multiple of 2 pi. You can write it like n into 2 pi, that is integral multiple of 2 pi. Where n is an integer 0, 1, 2, 3, so on. Of course, if n is 0, then phase difference will be 0. If n is 1, phase difference will be 2 pi. If n is 2, phase difference will be 4 pi. So in terms of phase difference, it should be equal to integral multiple of 2 pi. This is the condition for maximum intensity of constructive interference. And in terms of path difference, delta is equal to n lambda. How you can obtain this expression? You know the difference, relation between path difference and phase difference. What is the relation?
Two pi by lambda into
2 pi
path
by lambda.
difference.
2 pi by lambda into
Path difference.
path difference. But this expression equals to 2 pi by lambda, yes, this is equal to phase difference. So you can obtain the expression for path difference if you know the phase difference. So path difference is equal to lambda by 2 pi. If we denote path difference by delta, this is equal to this lambda by 2 pi into phase difference. What is phase difference for constructive interference? 2n pi. So the expression for this pi will cancel out. 2 will be cancelled out. So path difference is equal to n lambda. So this condition you should remember. Integral multiple of, yeah, phase difference is integral multiple of 2 pi and path difference is n lambda. Write this down. Condition for, yes. Your voice is not clear.
Phi equals to
Phi, yes, you can denote this delta with phi. If you want to denote the phase difference by phi, then phase difference is equal to 2n pi. Yes. This is what you are asking now. Note this down.
मैम
Yes.
मैम जो ये रिलेशन आपने बताया इसका डेरिवेशन क्या होगा?
डेरिवेशन मैंने ऐसे बताया ना फिजिकली. देखो ये फर्स्ट वेव है, ठीक है, ये सेकंड वेव है. कंस्ट्रक्टिव इंटरफेरेंस कब होगी? Then crust will fall on crest or trough will fall on trough. Suppose the phase, when we consider phase difference is equal to 0, phi is equal to 0, what will happen? First wave will be like this, second wave will also be like this. That's how the phase difference is 0. So the condition for constructive interference is met. When phase difference is 2 pi, what will happen? This complete wavelength will be shifted, right? So it will be like the first wave is like this and second wave will be like this is one wavelength and this is two wavelength. So what will happen is this will superimpose on this thing, which is shifted by an amount of 2 pi. But when you complete this wave, first one, it goes like this now. So again the crest will fall on crest when it is moved by 2 pi. Similarly, when the phase difference is 4 pi, first and second wave, again first wave will be like this, second wave it will be moved by 2 pi, 4 pi, and here 6 pi. It is here. When you complete this wave, it goes like this. Again, crest will fall on crest. These are traveling waves now. This is not standing wave like this. These are traveling waves. So it goes like this indefinitely with the time and with position. Clear? This is not
Yes,
the
ma'am.
standing wave that here is a wave and if it is moved by like this, so there will be nothing like that. It is a traveling wave. It will be replaced by another pulse of wave.
Okay, ma'am.
Yes, Aditya?
Noted, ma'am.
Okay.
Move on next slide.
Okay. So you tell me first. I'll then move to next slide. What will be the condition for minimum intensity or destructive interference? As you have obtained this condition for constructive, what will be the similar condition for destructive interference or minimum intensity?
n-1 lambda by 2 path difference.
N-1.
Yes,
It's
Two
correct.
minus
-1.
Yeah, but what does that mean? 2n-1 or 2n+1 by lambda by 2. What does this mean?
मैं मतलब ये lambda by 2, 3 lambda by 2, 5 lambda by 2 ऐसे जाएगा.
Yes. Okay, how you obtain this expression? Suppose the path difference is lambda by 2. What will happen? Suppose first wave is this. How will be the second wave? If the path difference is lambda by 2. From which point should I start? Over here. Should I go like this?
No, ma'am.
Then
No, ma'am.
how?
No, ma'am.
Then how?
Ma'am, downwards.
Ma'am,
Yes,
second
to the
to
downwards.
5
Yes.
5 by
Yes.
2.
If the wave path difference is lambda by 2, so it means half of the wavelength is shifted. So this
Yes,
will
ma'am.
not be, we will start like this. So you can see crest of first wave is falling on trough of second wave. And this is the case for destructive interference. When the path difference is 5 lambda by 2, it means you can write this down like lambda plus. How can you write this down?
2 lambda plus lambda by 2.
2 lambda plus lambda by 2.
So it means first you shift 2 wavelengths, then lambda by 2. Again, the result will be, you can skip like these 2 waves and then again lambda by 2. So result will be like this one. So when it is odd multiple of lambda by 2, when the path difference is odd multiple of lambda by 2, first wave and second wave, they will superimpose such that crest of first lies on trough of other and vice versa. And it is the case of destructive interference. So the condition in case of destructive interference is it is odd multiple of lambda by 2, the path difference, and phase difference phi or delta. This is equal to, how you obtain this expression again, you know, the expression for phase difference, this is equal to 2 pi by lambda into path difference. You know the path difference, so 2 pi by lambda into 2n minus 1 lambda by 2. So lambda cancel out, 2 cancel, so it is 2n minus 1 into pi. Write this down. The condition for minimum intensity or destructive interference.
Ma'am, can you
Hmm.
explain again the derivation of destructive interference?
Okay, so if this is the first wave, in terms of path difference, if I consider, first you put the value of n to be 0. It can be 2n plus 1 or 2n minus 1. The conclusion is it should be odd multiple of lambda by 2. So odd multiple of lambda by 2, first we take 1 into lambda by 2. Delta is equal to, this expression means delta is equal to lambda by 2, 3 lambda by 2, 5 lambda by 2, and so on. Okay, we'll consider that delta is equal to lambda by 2 first. It means the first wave and second wave, path difference between these two is lambda by 2. How the lambda by 2 path difference comes? If half of the wavelength, it means half of lambda, na? Lambda by 2 means half of lambda. This is lambda by 2. So half of the wavelength is shifted. So in the first wave, you are starting from this point, but in second, you have to shift this wavelength by half of lambda. So this half portion will be shifted. So the wave will start from this point. So in this case, it is clear that crest falls on trough and trough of first falls on crest of second. And you know, when crest falls on trough, the resultant amplitude is zero. And this is the case of destructive interference. Is it clear now?
Yes, ma'am. Thank
Yes,
you.
ma'am.
Yes, ma'am.
Yes, in
Yes,
case of 3 lambda by 2, you can similarly write this down. This is equal to lambda plus lambda by 2. So you have to shift the wavelength
plus
by
lambda by 2.
one wavelength and an extra of half of wavelength. So again, this wave will be like this. Okay. So actually, we did not go into detail for the derivation of interference pattern. So what was the like experimental arrangement? This was the source S from where light came out, and then there were two slits, S1 and S2. Light goes into these slits. This is a screen on where we are observing the interference pattern. So light from these two slits, it superimpose on each other to form the interference pattern. At this point, general point BP, this central point of the between the two slits on the screen corresponds to point O. So the resultant intensity at any general point P, when we derive this expression, T is equal to I1. I1 is the intensity due to first wave at point P. I2 is the intensity of second wave at point P at a general point P plus 2 under root I1 I2 cos phi, where phi is the phase difference between first wave and second wave when it reaches at point P. So this is a general expression for intensity at point, any general point on the screen. Write this down. If you know the expression for intensity, can you write down the expression for amplitude at point P?
Yes, ma'am.
So what will be the expression? In place of phi, what we will write? If A is the amplitude, net amplitude, resultant amplitude at point P, A1 and A2.
Square.
Yeah, A square
A1.
is equal to A1 square
A1 square plus A2 square
plus A2 square
plus 2A1 A2.
plus 2
A1 A2 cos
A1
A1
A2
cos.
cos phi. Correct. Also write this down. This is the expression for resultant amplitude in terms of amplitude. So A is equal to under root of this thing. At any point P on the screen.
Ma'am, is it a part of syllabus?
Yes, interference in and diffraction, it will be constituted in wave optics. So your third unit is wave optics. So interference, like this is the basic thing you have learned in your class 12. In your first semester, the interference will be different types. I'll discuss in my next slides, but you will study. I will not go into detail of those topics, just give you the overview of what topics you will cover in your first semester. But yes, you need to know these things for your wave optics unit.
Noted, ma'am.
Okay.
Uma ma'am.
So solve this numerical then.
Sixteen ratio 1.
16:1.
Yes, correct. Others also solve this.
Yes, ma'am. 16 ratio 1.
Yes. So for the maximum intensity,
64.
A maximum square is equal to A1 square plus A2 square plus
Plus 2.
2A1 A2 cos phi. What will be phi for maximum intensity? Phase differences
0.
0 or integral multiple
0.
of 2 pi and so on up to. So we'll consider cos integral multiple of 2 pi. 2 and pi, you can say it can be 0, it can be 2 pi or anything. Cos 2 and pi is 1. So it will be a1 square plus a2 square plus 2 a1 a2, which is equal to a1 plus a2 whole square. A1 is given to be 5 units. A2 is given to be 3 units. So A maximum is equal to 8 square. So A maximum is equal to 8. Similarly, we can find A minimum. In that case, what will be the phase difference? What will be 5?
Odd multiples of pi.
Yes. Yes. And cos of odd multiple of pi, let's say pi, which is an odd multiple of pi. Cos pi is -1. So odd multiple of pi, that cosine is equal to -1. So it will be -2 a1 a2. This is equal to a1 minus a2 whole square, where it is square. So A minimum is equal to a1 minus a2. A1 is 5, a2 is 3, so it is 2 unit. And we have to find the ratio of maximum to minimum intensities. This is equal to A maximum square upon A minimum square. A square divided by 2 square. This is equal to 16 is to 1. So this is the ratio of intensities. Note this down, who have not solved this, and we will continue this interference topic in our tomorrow class. Yes, Rupesh. I'm going to stop sharing the screen. We'll continue from this in a tomorrow's class.
Ma'am, attendance.
Thank you, ma'am.
Yes,
Ma'am,
I'm
attendance.
taking the
Thank you, ma'am.
attendance. Yes, yes.
Okay,
Thank you,
Thank you,
everyone.
ma'am.
Thank you, ma'am.
Thank you.
Thank you, ma'am.
Thank you, ma'am.